Okay, so we're going to finish off this review package, then we'll go through the two quizzes you guys wrote. Come here, please. We'll go through those two quizzes, and that'll get you ready, hopefully, for your test on equations and inequalities, which is tomorrow. So, on page 4, a couple problems to look at. It says a snowboard shop offers 2 different rental plans. Plan A is $5 an hour, or Plan B, there's a sign-up fee of $10 and an extra $2 per hour that the equipment is rented. If n equals the number of hours that a snowboarder plans to rent the equipment, write an equation to determine the time in hours that results in the same cost for both plans. So that'll be where both plans are equal, an equal amount. So this will be an equation. We are told that n will be the number of hours that a snowboarder plans to rent the equipment. So for plan A, it's just a flat rate of $5 per hour. So that would be 5n. And that must equal the amount in plan B, which is $10 plus $2 per hour. And again, n is the number of hours. So there is our equation that we need to solve. Merrick, do you have your review stuff from yesterday? Were you here yesterday? Where's your review stuff? Pardon? You didn't get the review notes? Okay, come grab. So there's the notes. Did you get the review assignment? There you go. Okay, so there's our equation that we want to solve. What is n? What value of n makes the two amounts equal? So I would start by subtracting 2n from both sides. On the right side, the 2n cancels. On the left, 5n take away 2n is 3n, and that equals 10. And then to get n by itself, we would divide both sides by 3. And in this case, we're going to get a decimal. Right? The 3's cancel, and you have n equaling 10 over 3, which is 3.3 repeating. 10 divided by 3, 3.3 repeating. So we'll say approximately 3.3. So if they charge by part of an hour, that's our answer. After 3 1/3 hours, or 3 hours and 20 minutes, because 1/3 of an hour is like 60 minutes divided by 3. That's where the 20 minutes comes from. So if they charge by parts of an hour, that's our exact answer. Okay. Number 4 says, for each number line, write the inequality represented, include whether real numbers or integers are indicated. So a line means real numbers, where dots mean integers. So you can see in part A, we have real numbers because lines are used, where in part B, we have integers because dots are used. For question A, there's going to be 2 pieces to that. The first piece on the left, it starts at -3, and because the dot is colored in, that means the -3 is included, and then it goes to the left. So we could say x is less than or equal to -3, comma. The other side starts at 2, and because there's an open dot there, the 2 is not included, and it goes to the right. So we can say x is greater than +2, and once again, because lines are used, that means all fractions and decimals are included in this, which means we're dealing with real numbers. And for question B, because there's dots, that's integers. It's only those numbers specifically, not the decimals in between. It starts at 1, which is included because the dot is closed, and the arrow's going off to the left here, which means that that pattern continues. Well, it's hard to know whether that is actually, I think that arrow there is same as the arrow on the right. It just shows that the number line is going to the left forever. So we'll consider there's no arrow here, meaning it's just these specific values. So we can say that x is greater than or equal to -4, comma, x is less than or equal to +1, and x is an element of integers in this case. Okay, so the next one. Again, a line is used, which means it's real numbers. It starts at -2, and that value is included because the dot is colored in, and the arrow goes off to the right. So we would say in this case that x is greater than or equal to -2, and once again, x is an element of real numbers because it's a line. Question D is also a line, so that's also real numbers, but it has a starting point and an ending point. In this case, we could say that x is greater than or equal to 1 because the dot on the 1 is colored in, but it's only less than 6 because that dot is not colored in. And once again, because it's a line, x belongs to the set of real numbers. Right, so there's that inequality written. Now, when you have a starting point and an ending point, we said before that you could write it as one statement. So for this last one, and you always go smaller number to bigger number, x is greater than or equal to 1 or less than 6. That could be written like that. Question B could be written in the same way. -4 greater than or equal to x, less than or equal to 1, and again, x is an element of integers. So either way is fine. It doesn't matter. Two separate statements or one continuous statement. You just have to make sure that your inequality symbols are pointed in the right way. And if you go from smaller to bigger, like I did in both these examples, the inequalities are always pointed to the left in each case. So if you look at that, you'll see that all the inequalities are pointed to the left. When you write it as one complete statement instead of two separate ones, and you have a smaller number first, a larger number second, they're always pointed to the left. Okay? Number 5, Aaron has a collection of loonies and toonies. Each toonie is worth $1. Each loonie is worth $1. Each toonie is worth 2. She has 4 times as many loonies as she has toonies, and the total value of her money is $48. How many of each coins does she have? So when we did questions like this, we talked about the fact that you can only have one variable in the equation. And we are told that she has 4 times as many loonies as she has toonies. The number of loonies is 4 times the number of toonies. So if I let t equal the number of toonies, then the number of loonies is 4 times that. So 4t would equal the number of loonies. So now we have an expression for each type of coin in terms of the same variable t. So now we can write our equation. Okay, she has a total value of $48. Each toonie is worth $2, so 2t plus. Each loonie is worth $1, so 1 times 4t has to equal 48. 2t plus 4t is 6t. Those are like terms. They both are in terms of the letter t. And now to get t by itself, we would divide both sides by 6. And that gives us an answer for t to be 8. So he has 8 toonies. That's what t is. And the number of loonies is 4 times that. 4 times 8 is 32. So just as a quick check, the first thing is that the number of loonies is 4 times the number of toonies. 4 times as many loonies as he has toonies. So that part works out. The other part is that there has to be a total of $48 there. So this is our check. 8 toonies, and each toonie is worth $2, plus 32 loonies, and each loonie is worth $1, should equal 48. 8 times 2 is 16, plus 32 does equal 48, so it checks. Our answer is correct. The number of loonies is 4 times the number of toonies. That's the first criteria. And the total value is $48. That's the second criteria. So they both work. Rectangular table has a length of 2.8 meters. So this is 2.8. This is 2.8. And a total perimeter of 8.2 meters. If W is used to represent the width of the table, write and solve an equation to determine the actual width of the rectangular table. So the perimeter is the distance around. You add up all the sides. So you'll have 2 W's plus 2 lengths, but we're told the length is 2.8 meters. That would give us the total perimeter of 8.2 meters. So there's our equation that we want to solve. Perimeter is the distance around. You add up all the sides. So on the left, we can multiply the 2 by the 2.8 and get 5.6. I think. Let's just check to make sure. 2 times 2.8. And then we would subtract that 5.6 from both sides. So they'll cancel on the left. We'll have 2W by itself. 8.2 take away the 5.6 on the right is 2.6. And then we'll divide both sides by 2. And that'll get the W by itself, and that'll be 1.3 meters. So to make sure, if we add up all 4 sides, it should equal 8.2. Two W plus 2 lengths has to equal 8.2. Let's fix that. So on the right side, we have 8.2. On the left side, 2 times W, which we found to be 1.3, plus 2 times the length, which we found to be 2.8. So 2 times 1.3, that's 2.6. 2 times 2.8 is 5.6. If we add those two together, we should get 8.2, and we do. So it checks. It checks. Number 7 says if a number n is tripled, then decreased by 12, the result is 39. Write and solve the equation to determine the original number n. So the number is n, and it's tripled, which means you multiply it by 3. And then decrease by 12, so subtract 12. The result is, or that equals, 39. So there's the equation that we need to solve. So we'll add 12 to both sides first. On the left, the 12's count, so you're left with 3n equals 52. No, sorry, 51. And then we will divide both sides by 3. And I think that will give us an answer of 17. 51 divided by 3. Yep. So as our check, the number is triple, that's 3n, decreased by 12, should equal 39. So 3 times 17, take away 12. 3 times 17 is 51, take away 12 is 39, so it checks. Okay? So that's the review for the test tomorrow. So now we'll go on and review those quizzes. So when I call your name, you can come get your first quiz. Wayne, you didn't write this, so I'll excuse it, but you can fill in the blanks on that. Danny, come get your quiz. Merrick, come get yours. Alicia, there's yours. Courtney, Beckham, Hannah, Kate, Christy, Liam, Courtney, Stanley, Riley, Arpit, Callum, Jackie, Charlie, Keen. Okay, I think that's everyone. If you didn't get yours. Okay, Lena, there it is. All right, so correct your mistakes. Learn from them. You're going to have to do this stuff tomorrow on the test, so correct your mistakes and you can use your quiz as a study tool. Would be a good idea tonight. Take it home, look at the question, cover up the answer, your corrected one, and make sure you can do it without looking. That's how you know if you are ready for this test tomorrow. So for the first one, it says solve each equation, check your answers. So again, when it says check your answers, that's worth, or it could be worth a mark. And if you don't, you might lose. So make sure you check if you're told to. For question A, you're going to multiply both sides by 6 because the A and the 6 are hooked together by division. And we always do the opposite. And so what happens on the left, the 6's cancel because 6 divided by 6 is 1. So you'll get 1A or just A equaling 48. And if I look at the original equation, it says that A divided by 6 or 48 divided by 6 should equal 8, and it does. So it checks. Question B. Here I would add 6 to both sides. The h and the 6 are hooked together by subtraction. The opposite of subtracting is adding. So we'll add 6 to both sides. They cancel on the left. I'm left with h, and on the right, negative 19 plus 6 is negative 13. So that's the answer that we get. And if we check it, on the left, h, which is negative 13, take away 6, should equal negative 19, and it does. So it checks. Question C, those two are hooked together by multiplication. So we would divide both sides by 1.5. And so on the left, the 1.5's cancel. We'll have h by itself. And on the right side, negative 7.5 divided by 1.5, I think, is negative 5. Negative 7.5. Whoops, I forgot the negative. Negative 7.5 divided by 1.5 is negative 5. So if we check it, 1.5 times h, which is negative 5, 1.5 times negative 5 does equal negative 7.5, so it checks. For the last one, that 5 is a positive 5, so we'll have to subtract 5 from both sides. So on the left, 5 minus 5 cancels. You're left with d equaling 18 take away 5 is 13. And if you check that, 5 plus 13 does equal 18, so it checks. These next ones are two-step equations. Question A, the first thing you would do is subtract 7 from both sides. On the left, the 7's cancel. You're left with negative 4c equaling 47 take away 7 is 40. But we still won't have c by itself, so now we would divide both sides by negative 4. Right, and this is an equation, so dividing by a negative doesn't change anything about the equal sign. It only happens when we have inequalities. So negative 4 divided by 4 cancel, and so you'll have c by itself on the left. On the right, 40 divided by negative 4 is negative 10. So there's our answer, and this time I'll show the check. Just a reminder of what's required if you're showing your check. Again, if it's worth a mark and you don't do it, you're going to lose. So you need to show that you get the same number on both sides. Negative 4 times negative 10 is positive 40, and 40 plus 7 is 47, so it checks. That shows that the answer is correct. Question B, I would multiply both sides by 3 first to get rid of the denominator of 3. So 3 divided by 3 cancels, and we'll have y plus 5 on the left equaling negative 3 times 3, which is negative 9 on the right. Then we will subtract 5 from both sides. So they cancel on the left. And on the right, negative 9 take away 5 is negative 14. And again, if you're not sure, use your calculator to go negative 9 take away 5. If you do that part wrong, it's going to give you a wrong answer, which you would know if you checked it. Y plus 5 all over 3 should equal negative 3. So it's negative 14 plus 5 all over 3. And negative 14 plus 5 is negative 9. Divided by 3 is negative 3, so it checks. Our answer is correct. Question C, I would add 6 to both sides as a starting point. On the left, the minus 6 plus 6 cancels. You have x over 3 equaling, on the right, negative 22 plus 6 is negative 16. And then we would multiply both sides by 3 to get x by itself. So on the left, 3 divided by 3 cancel. We have x by itself. And on the right, negative 16 times 3 is negative 48. So there's our answer, and that's what we need to use in our check. Negative 48 divided by 3 is negative 16. And negative 16 take away 6 is negative 22, which I forgot to write the negative sign on the right. Negative 22. So it checks. We've just shown that our answer is correct. It works. Right, number 3. First step there. And we saw ones like this yesterday in our review. I think we can divide both sides by 4. It just saves us one step. 8.2 on the right divided by 4 does equal 2.05. So that's what I would do first here. I would divide both sides by 4. And when that does, it gets rid of the 4. You have a minus 3.6 on the left. And on the right, you'll have 2.05. And then we would add the 3.6 to both sides. So on the left, negative 3.6 plus 3.6 cancel. You have a by itself. And on the right, you'll get 5.65. That should be our answer. That's what we'll have to put in our check. So 5.65 take away 3.6. 5.65 take away 3.6 is 2.05. And if you multiply those out, you will get your 8.2. So it checks. We just showed that our answer is correct. Question B. I will collect the A's together. I'm going to subtract 2A from both sides. So on the right side, the 2A's cancel. And on the left side, 3.5A take away 2A would be 1.5A. Then I would add the 4.6 to both sides. And let me fix, that should be negative 1.3 there. So on the left side, The 4.6's will cancel. I'll have 1.5a. And on the right side, it'll be negative 1.3 plus 4.6, which would be 3.3, I think. Yeah. And then finally, we would divide both sides by the 1.5. So the a 1.5's cancel, and you'll have a by itself. And on the right side, 7.3 divided by the 1.5. Something's wrong here. Let's see here. I subtracted 2a from both sides. That's 1.5a minus 4.6 equals negative 1.3. That's right. And then I added the 4.6 to both sides. It's not 7.2, I think, not 7.3. Let's just check that. No, it's 3.3. That's right. It's not 7.3, it's 3.3. I put 7.3 in my calculator because I didn't do a good job of writing that 3 there. So let's try that again. 3.3 divided by 1.5. There we go, 2.2. That's better. So there's our answer. And I'm kind of running out of room to check here, so let's just do it on the calculator. On the left side, 3.5 times a, which is 2.2, minus 4.6 gives us 3.1 on the left, so we should get the same thing on the right. 2 times a, which we found to be 2.2, minus 1.3 also gives us 3.1, so it checks. I just didn't have room to really show it here. Question C. In this case, because you got a bunch of denominators, I would get rid of the denominator by multiplying everything by the common denominator. The least common multiple of all these numbers, 2, 4, and 3, would be 12. So I'm going to multiply every term by 12. And the reason we do that is because we can divide. 12 divided by 2 is 6. You'll have 6m. Plus 12 divided by 4 is 3. Times 1, there's a 1 there, is still 3, equals 12 divided by 3 is 4, times the 2 up top. 4 times 2 is 8. So by multiplying all the terms by 12, I get rid of the denominators. And now I can just solve for m by subtracting the 3 from both sides. So on the left side, the 3's will cancel. You're left with 6m equaling 5. And then m will equal 5 over 6 when you divide both sides by 6. And just as a quick check here, I'll use the calculator. So the original expression was m over 2. So 5 divided by 6 divided by 2 is that value. And then you have to add 1/4 plus 1 divided by 4. So it gives us 0.6 repeating, which is 2/3. And that's what the right side is, 2/3. So it checks. It checks. Question 4. Pasha has a box with 40 coins consisting of quarters and nickels that are worth 460. How many of each coin does she have? So again, we need to come up with an expression for both type of coin, quarters and nickels, but only involving one variable. So if we let Q equal number of quarters, now I know that I can only have one variable in the end, but I'm going to introduce a second variable just to help us here. So if we originally say that n is number of nickels, and again, at the end, I can only have one variable in my equation, but I'm going to get there because we were told that she has a total of 40 coins. So Q plus N would equal 40. And if I wanted to write N in terms of Q, if I take this and subtract the N from both sides, actually, yeah, that's fine. That's going to give me Q equals 40 take away N. So what I did actually is wrote the number of quarters in terms of the number of nickels. Originally I said Q was the number of quarters. Now I can say it's also 40 take away N. And now we have only one variable. N being the number of nickels, 40 take away N being the number of quarters. So now when I write my equation here, each quarter is worth 25 cents. So 0.25 times the number of quarters, which is 40 take away N, plus each nickel is worth 5 cents, 0.05 N. Altogether, that has to equal $4.60. So there's my equation. If you multiply out the brackets on the left, 0.25 times 40 is 10. Take away 0.25 times N. I can simplify on the left. If I combine the negative 0.25 N plus the 0.05 N, that'll give me negative 0.2 N. I'll then subtract this 10 from both sides. They'll cancel on the left, and I'll have negative 0.2 N equaling 460 minus 10. 4.60 take away 10 is negative 5.4, negative 540. And then we would divide both sides by negative 0.2 to get the N by itself. So that negative 5.4 divided by negative 0.2 is 27. So that's how many nickels there are, 27. Q, the number of quarters, is 40 minus N. So 40 minus 27 is 13. So that should be our answer for the number of quarters. If we add the 13 and the 27 together, we will get 40. Our other check that we should do is the value of these. The number of quarters is 13 times 0.25 per quarter, plus the number of nickels is 27 times 0.05 should equal 460, and it does. So it checks. So there's the answer, and you just want to write a concluding statement there. Okay? So again, hopefully you corrected your mistakes. You can use this to study for your test tomorrow. Again, cover up the answers. See if you can do the questions without looking. Okay, quiz 2. Merrick, come get your quiz, please. Danny. Christy. Beckham. Charlie. Alicia. Jackie. Yep. Wayne. Callum. Hannah. Stanley. Liam. Lena. Kate. Keen. There's yours. Lena, there's yours. Courtney. Shyla. Arpit. Riley. Okay, that's everyone. Yeah. Okay, so let's go through this one. So again, it says graph the inequalities. So the first one, x must be less than -8, and x is an element of real numbers, which means you're going to have an open dot on -8. And because it's less than, the number line will go to the left, and it's a line because x is an element of real numbers, which means all fractions and decimals. Okay? Guys, put your phones away. You should be paying attention here. Question B. X is an element of integers, so now we're just going to use dots. It says x is greater than or equal to -3, so the -3 is included with a closed dot because it's equal to -3, as well as greater than, so now we have to go off to the right with dots, and we put an arrow on there to show that that pattern continues. Question C, back to real numbers, so we'll use a line. It says x is greater than 10. So we'll have an open dot on 10 because the 10 is not included, and now a line going off to the right with an arrow on the end because x must be greater than 10. Values are bigger than 10. And again, it's a line because it's real numbers. Number 2 is the opposite. You're given the graph, you want to write the inequality. Okay, so this one starts at -1, which is not included, and there's a line going off to the right. It's the bluish colored one. And so this would be x, x is greater than 1, and because it's a line, x is an element of real numbers. You have to include the number system there. Question B are dots, so that's integers. It starts at 3, and notice the big thick arrow going off to the left. So we would say x is less than or equal to 3, only now x is an element of integers. Question C, we're back to a line, so that's real numbers. This has a starting point and an ending point. So remember I said if you start from smallest number to biggest number, and the inequalities will always point to the left. The -3 is included, the 2 is included, so I have less than or equal to signs for both parts, and again, because it's a number line, x is an element of real numbers. Number 3, solve the inequality, graph a solution on the number line. Question A, you just simply divide both sides by 2. The inequality does not reverse, and if you read from the x, it says x is greater than 5, meaning not equal to 5, so we have an open dot on 5, and it goes off to the right with a line because it says x is greater than 5, and we use a line because it's real numbers. Try that again. There we go. Question B, to get x by itself here, we would add 13 to both sides. And on the left, 2 plus 13 is 15. The inequality does not change. We have x by itself on the right. X is less than or equal to 15. Means the 15 is included. So a closed dot on the 15. And because it's less than as well, we go to the left with dots because x is an element of integers. So you need that arrow there to show that that pattern continues. So there's the answer for question B. Question C. In this case, I could divide both sides by -4 as a starting point. On the left, 4 divided by -4 is -1. And because we divided by -4 so that those -4s will cancel, the inequality reverses because we divided by a negative. And then we're just left with the 3x minus 7 on the right. So we can add 7 to both sides. On the left, -1 plus 7 is 6, which will be greater than 3x. And now we would divide both sides by 3 to get the x by itself. So 6 divided by 3 is 2, and that will be greater than x, or x is less than 6. Which means that the 6 is not included, so an open dot. Less than meaning the line goes to the left, and it is a line because it's real numbers. So there's the solution. And as I showed you before, you can check these still. If we use a real number less than 6, like 5. So let's check here. That's a number less than 6. So 4 should be less than -4 times 3x take away 7. So this is our check. The number on the left should be less than the number on the right. So 3 times 5 take away 7. I'm just going to check things over here one more time. So I divided both sides by -4. That gives me -1 on the left, and my inequality did reverse. So I added 6 to both sides, 7 to both sides, excuse me. -1 plus 7 is 6. Oh, I divided by 3, and I wrote x is less than 6. It should be x is less than 2. Kyler, here's this quiz. Did you sign in?
Yeah.
Okay, just hold on a second. There's another one here for you that we went through. So I have to use a number less than 2, not 6. So let's check using 1. So it's -4 times 3.1. 3 times 1 take away 7. 3 times 1 is 3. Take away 7 is -4. And -4 times -4 is +16. So it checks. The number on the left is less than the number on the right. So it checks. Question D. I would subtract 7x from both sides as a starting point. 15x take away 7x is 8x. Plus 35 greater than or equal to -21. Then I would subtract the 35 from both sides. So on the left, the 35's cancel. You'll have 8x greater than or equal to -21 take away 35 is -56. And when you divide both sides by 8, x will be greater than or equal to -7. So as a check, I have to use a number greater than or equal to -7. What about -6? That's greater than or equal to -7. So 15x plus 35 has to be greater than or equal to 7x minus 21. I'm going to check using -6. So 15 times -6 is -90. Plus 35, I think, is 55. Yeah, negative, yeah. And that should be bigger or equal to the number on the right. 7 times -6 is -42. Take away 21 is -63, and it works. The number on the left is greater than or equal to the number on the right. So on the number line, we have -7, and because x is an element of integers, I'll use dots. And because x is greater than or equal to -7, our dots go to the right with an arrow on there to show that that pattern continues. Number 4 says Keith has $500 in a savings account at the beginning of summer. He wants to have at least $200 in the account by the end of the summer and withdraws $25 each week for food, clothes, and movie tickets. Write an inequality that represents his situation. So he has $500 in the account. He's going to withdraw $25 each week. So if I say that n is the number of weeks, the amount he withdraws is 25 each week, or 25 times n. And he wants to have at least $200 in the account still, so that amount has to be greater than or equal to 200. There's our inequality. And then to solve it, that'll tell us how many weeks Keith can withdraw the money from his account. We're going to solve this inequality. So if I start with it again, I'll subtract 500 from both sides. They'll cancel on the left, but I still have negative 25n there. And on the right, 200 take away 500 is negative 300. And then when you divide both sides by negative 25, the inequality is going to reverse. Instead of greater than or equal to, it will be less than or equal to. And on the right, negative 300 divided by negative 25 is positive 12. So n has to be less than or equal to 12. He can withdraw the money for 12 weeks, but no more. And then he'll still have at least $200 in his account. Okay, so again, use these quizzes for your review. Cover up the answers. Make sure you can answer them without looking. That'll tell you if you're ready for your test, which is taking place tomorrow. Okay? So make sure you spend some time reviewing and studying. Also, remember, it's your responsibility to make sure you got all your assignments in. The review assignment that I gave you yesterday is due for marks. That's got to be handed in. If you didn't get it, you need to ask me for another copy or a copy of it. Okay, so you have